Yeah, so to share all the work that Resilient Waters has been doing for the last couple of years now, really, since we've had one of these bigger network meetings. We've had those kind of solutions webinars, but we haven't given you many updates on what's been happening with Resilient Waters. So this should be a fun meeting. Normally, we had been hoping that Tyrone, Tribal Chief Stolo Council, Tyrone McNeil, would be joining us to provide a little welcome, but he's wearing one of his many hats and speaking at the School Trustees Association general meeting, I think, today. So if there is anyone in the crowd today that would be up for or feel comfortable for saying a few words and giving a welcome and starting off our day, then that would be welcome. I'll leave a few seconds or maybe 10 seconds or so. Okay, well, thanks very much. So I'll just say from my side of things, I'm here on the unceded territories of the Squamish and Musqueam and Tsleil-Waututh in Vancouver. You can type into the chat group any the territories where you are residing into the chat box. And I just want to say on behalf of Resilient Waters, start by acknowledging that most of us are gathered on the mainland Coast Salish First Nations. I think some of us might be a bit further afield, depending on where you're coming in from. And I think it's important for us settler folks like me to take a moment to acknowledge the truths and harms of settler colonialism, systemic racism, and their ongoing effects on First Nations, and particularly the subjects that we're talking about today, flood risk and salmon loss, and I guess you could also add COVID into this, have disproportionate impacts on First Nations people of the Lower Fraser. And make this connection that the systems that are designed to control water and flooding are born of a similar settler mentality that was designed to control Indigenous bodies, forcefully displacing First Nations from their lands onto reserves, and often directly in harm's way on floodplains. Most reserves are located on the floodplain of the Lower Fraser, as you can see in this map, and the orange boundaries are First Nations reserves. And I've seen a recent paper that was estimating that probably 90% of reserve lands across Canada are in floodplains. So this is a pretty systemic issue. And I'm taking the time to say this because I'm hearing from Indigenous people for a long time now that many of us settlers, particularly white, are eager to move to reconciliation and are quick to skip uncomfortable truths. But this is our history too, and there's much work to be done by settlers, and particularly white ones like myself, to confront the barriers in our own white-led institutions and our white bodies and histories first. So on behalf of Resilient Waters, we are doing our best to listen and learn about how we can do this for ourselves in the project, and acknowledge that we will make mistakes and commit to doing better. So we are happy to receive any feedback or corrections or ideas about this. So please feel free to let me know that, provide that kind of feedback. Yeah, so we will move along. Actually, I'd like to hand it over to Gillian Fuss, who works with us through the Emergency Planning Secretariat and touches on a lot of what I was just talking about. So Gillian, over to you.
Thanks, Dan. Good morning, everyone. Sorry about my voice. I am recovering from COVID from a couple of weeks ago. Yeah, thank you very much for that. Yeah, for I guess what you were saying, Dan, that really resonated with me. So yeah, I really appreciate that. It's a good way to start off the meeting. So the Emergency Planning Secretariat is a relatively new body in the Lower Mainland. We work with 31 mainland Coast Salish First Nations from Yale to Semiahmoo to Squamish. And we're looking at improving mainland Coast Salish emergency planning, climate adaptation, and emergency response capacity. So all of those things wrapped up into one. Following the Sunday framework, that sort of stresses that instead of just looking at one or two methods of resilience, instead of looking at several. So how can we improve the resilience of our systems in general, our land use planning, things like that, but then also have really robust emergency plans, emergency response procedures, and really robust collaborations between First Nations communities and between First Nations communities and their neighbors. So how are we doing this? We're working with each community to understand where they are and what their individual goals are for where they would like to be in terms of their emergency capacity, their climate adaptation, things like that. And then working together as a region to develop a regional plan, which we're calling Helix Kaka, which means get ready together in Hokumelam, which is really exciting. Again, based on the Sunday framework, we have the 4 priorities of the Sunday framework in there. And then we've also added a 5th pillar that is about emergency capacity or emergency response capacity and tactical capacity. So building up sort of the number of people in communities and the number of trained people so that communities can effectively respond and effectively continue to plan. So we're just in the development stage of that. We hope to start engaging that as of we hope to start engaging in March, but naturally everything takes a little bit longer. So hopefully in May. And then in addition to that, we provide support to communities as they're building out their emergency plans, as they're looking to improve. During the flooding, we were supporting communities in their emergency response, and then in preparing for freshet and preparing for the next atmospheric river, supporting those processes, and then also advocating at higher levels. So together with Resilient Waters, we've been really enjoying working on this project because it's a really cool way of bringing people together and having conversations around fish-friendly infrastructure and how can we make actual change in the system that we have right now. But we've also been coming together as a different group and talking about how can we use this opportunity of, it's hard to think of it as an opportunity, but the November floods were an opportunity where there was so much destruction that gives us a chance to sit back and think about what's broken about our flood system and how can we go back and fix it. So how can we go ahead, not in the same direction, but go ahead in a different direction that will better suit our purposes and make us better prepared for climate change and other things. So we've been supporting, specifically our chair, Tyrone McNeil, has been participating on that and writing letters to the ministers and advocating for a number of things, including Build Back Better Together, including more fish-friendly infrastructure, and just generally multi-valued systems of planning as opposed to sort of the single system or all eggs in one basket system that we have right now. So thank you. Happy to be here.
Thanks so much, Gillian. Yeah, and we'll be able to get into some of that as well later. Lina will give a little presentation on that work too, but it's important stuff, so it's good to touch on many times. Thanks, Gillian. So now we'll get back to the business. So yeah, just to give everyone a little overview of what you're in for today. I know it's a bit of a longer Zoom meeting, and I know we've all got Zoom fatigue at this point, so happy that you're sticking with us here. I'm going to give a little bit of a quick overview of what the Resilient Waters Project is, because it might be new to some of you. And then we're going to go through a few presentations in 3 kind of buckets. The first one is on the research that we've been doing. The second is related to the actual restoration work, and then kind of broader systems change, some of which Gillian alluded to, and Lina's Azeez will be leading on that from Watershed Watch Salmon Society. And then we'll have some time for breakout groups. I estimate that we're going to be trying to get into those breakout groups a little bit before 11 a.m. So I know it's a lot of information to get through before we get there, but it would be great to have you all participate in those, and we can chat about any and all of the above. Basically, we're going to break out into those 3 buckets essentially, and you'll have a chance to drop into 2 of the 3. So you can, I think we're going to set it up so that you can select, but we might have to wrangle some people if there's not enough in each group. So yeah, looking forward to that. And before we move on, I want to just do a quick set up a poll. So I think you should be seeing a poll hopping up in front of you. It has two questions. The first one is, who is who in the zoo? So you can click on that. It's multiple choice, just in case you wear multiple hats as well. And then the second question is, what aspects of work are you most interested in and that you work on already? You can interpret that however you like. I imagine some of you might be clicking on all four. Okay, great. Got 42 out of 50 responses, 44. They're coming in hot. Okay. So I'm going to the end poll and share those results. So you should be able to see who's who here. We got a lot of the NGOs, but a pretty even smattering of folks from across sectors, which is great. And in terms of what aspects people work in, there's also pretty good diversity of people interested in all these different bits. So thanks for playing along and sharing that. We'll hop along to the next little portion here. So just quickly, as you probably know, when the robot voice told you, the meeting is being recorded. Also, you can rename yourself by right-clicking on if you find your name in the participants tab at the bottom of your Zoom window. You can rename yourself, and if you want to add your name, organization, pronouns, anything you like there. And then in the chat box, we'd love, I know we're not in person, so if there's things you want to like chime in and repeat, things that you like, people are saying, share URLs and resources or things you're working on, ask clarifying questions or answer questions if you have an answer. You can make a joke, or you can have some cheeky private side chats, which I often do when I'm in Zoom meetings. So feel free to do any and all of those things. And I'm going to get right into kind of an overview of the Resilient Waters project now. So some of you are maybe even at this event. This is all very linked to work that Lina Azeez was leading with Watershed Watch Salmon Society and the Connected Waters program since 2016. And Watershed Watch hosted a big forum just almost 3 years ago now to talk about this overlap of flood management and floodplains, salmon habitat, and flood infrastructure, and agriculture. All sorts of things were looped into that. So it was bringing together a lot of the same kinds of people that are here today. So covering this from many different aspects. And it was around the same time that the BC Salmon Restoration Innovation Fund was coming into play. So through various channels, essentially that this project got launched underneath the Make Way Charitable Society, who I work with, to actually get to work on the implementation side of working on the flood infrastructure restoration and restoring some of these off-channel habitats in the Lower Fraser. So when we're talking about this flood infrastructure, we're primarily talking about floodgates, like pictured in the top left here, pump stations as pictured in the top right, or dikes pictured on the bottom. And these are pieces of aging flood infrastructure, many built between 1950 to 1970 and are reaching the end of their service lives, many not equipped to handle what's coming with climate change. especially. So Resilient Waters was born and is trying to touch on many of these issues, like was talked about at the forum in 2019. At this kind of intersection of flood control infrastructure, we're really talking about a lot of different things: salmon ecosystem health, adapting to climate change, sustainable economies, protecting communities, agriculture, food security, reconciliation, and cultural preservation, all overlapping and intermingling, and all within this Lower Fraser watershed, from Richmond to Hope, or Tsawwassen Musqueam to Seabird Island and Yale. So this is one of the fastest growing regions in North America, some of the most productive and fertile agricultural land, and also some of the most expensive land, and home to 31 First Nations, 25 local governments, 3 million people. So there's a lot to dig into here. And when we're talking about the salmon side of things and these off-channel tributaries, and we're talking about 1,500 kilometers of off-channel kind of streams and tributaries off the main stem Fraser that have been disconnected by flood infrastructure. And these habitats are especially important for these overwintering juvenile salmon. So they need it to find refuge, feeding areas, adjusting to salinity closer to the estuary. It's very important habitat. It's been shown through lots of research that many of you are more knowledgeable about than I. Just a little moment to kind of tease apart what Watershed Watch and the Connected Waters program works on versus the Resilient Waters project. And there's a lot of overlap, so this isn't a perfect key, but the Connected Waters program is really a lot about advocacy, political support, research and best practices, stewardship events, public engagement and education, as well as cross-sector engagement like this. And then Resilient Waters is really more with implementation in mind of these restoration projects, and doing also research and best practices. And then we really overlap in these two areas of research, best practices, cross-sector engagement. So lots of overlap between us, but I guess the key is Resilient Waters is especially focused on the implementation of the flood infrastructure itself and identifying those opportunities. So just a very high level, and Patrick is going to get a little bit more into detail on this process, but just to give you the taste. So, and basically from the start of 2020 up to almost the end of 2021, a lot of effort has been going into identifying what those restoration opportunities are and then delving more deeply into them. Lots of research going into that and lots of engagement, especially lots of meetings and lots of relationship building, talking with First Nations and local governments about what the possibilities are, what the opportunities are, and what the interest is in moving on them. And you can see that map on our website, resilientwaters.ca. And then more recently, I mean, this is maybe a bit of a spoiler. There is actually going to be an announcement made by DFO at 11:30 today about some funding related to this work. I think it's okay that we share some of this work that's already underway. So we're getting into some collaborative research here. Mike Pearson will present on what he's been doing for 2021 and has already started to do for 2022, which is these fish and habitat assessments at 26 sites. Zachary Sherker from UBC's Pacific Salmon Lab is here with us today to tell us about the Colony Farm floodgate study. And then we'll have Shawn Chartrand from SFU Ecological Restoration tell us a bit more about this modeling of wetland evolution at the Addington Point Marsh. And then we'll have Lina Azeez tell us a bit about the work that's been going on in the systems change and best practices side of things. Like Jillian mentioned, the Building Back Better Together on flood recovery work with EPS. Some lit reviews and case studies that we've been working on floodgates and pump stations, as well as some cool animations that have been put together that have evolved over time. Some of you saw them in their early form. And then if you want to dig into some older stuff, we had hosted some solutions webinars in 2020 and 2021. Some of you were even involved in those as presenters. But without further ado, I'm going to hand it over to Mike to get us started on on some results of the field work that he was very busy working on with Watershed Watch folks last year. Over to you, Mike.
All right. Good morning, everyone. Pleasure to be here. You can see the presentation fine? Okay, good. So it was 2021 was an excellent field season in many ways, challenging in others. We had no fewer than 7 unscheduled shutdowns due to either extreme heat or COVID scares, or one of the crew got sick. We had to shut down for a few days, but no one actually got COVID. My downs. Oh, I see. Yeah, so we spent a total of 90 days in the field over the summer of 2021, spring right through fall, actually. We have fish and water quality sampling at 23 sites, had loggers in another 3 to make up 26. Most of those sites we sampled 3 times during the year, sort of before freshet, during high water, and then later on after the flows had subsided. Over the course of that, we collected about 400 genetic samples from juvenile Chinook and coho. About half of those were from resilient water sites, about half from the main stem Fraser and immediately outside of resilient water sites. So the fish that could use those habitats if they had access to them. We did a great crew. The bottom picture shows sort of the core crew from left to right. There's Mike Leon and Oscar Von Wall. Mike's with senior technician at Pearson Ecological. Oscar is now with KWL and on the line, but last year was an intern with Watershed Watch and embedded with us. Petra Wickbus, also Pearson Ecological. The far right's Megan Rooney from Watershed Watch Salmon Society, who, as Dan alluded to, sort of started this whole process and sort of assisted us within the field. Fellow in the center is Mike McCroskey from representing Coquitlam First Nation. We were fortunate in being able to work in the field at most of our sites with staff from the nations of whose primary territory we're in. That included Chiam, Lakamo, Coquitlam, Kwantlen, Seabird Island, and Catesy. We're also reserves and territory by Tsawwassen, Matsuka, and Skowlitz, but they were unable to join us in the field typically because of COVID and staffing constraints. But this year we're looking forward to continuing that work in all cases. So those are the sites. They range from Tilbury Slough in Delta in the west, all the way out to Seabird Island in the east. Right in the center, that's at Matsweed, right near Mission, McLennan Creek. Our fish methods, primary method that we used everywhere was traps, because you can use them in all different sorts of habitats. We use both G traps, or the commercially available ones that most people have seen, and fetish traps, which we make, which are the same principle. They work the same way, but are much larger, catch larger fish, give us a much better idea of sort of the fish community that's there. So if there's a lot of predators around, for instance, we pick that up with the fetish traps often. We use seines. These are particularly effective in sort of open habitats, especially usually outside the dike. And were the main way that we caught Chinook and chum, which don't tend to go into traps very well as juveniles. We also use pike net to very good effect in tidal areas. So this is one set at Addington Point. You can see it's sort of a barrel in the middle and it funnels like the traps, and then these wings. So we set it at high tide, and then as the tide goes out and the salmon are leaving the estuary, they get caught in there. Main target species were Anadromous salmonids. Coho, we all use these habitats in slightly different ways. Coho would spawn in a lot of tributaries, and rear in freshwater for a full year. So they're resident in some of these habitats inside the dike, or would be if they had access to some of the ones they don't. Steelhead was our anadromous, but rainbow trout and cutthroat trout can also be resident behind the dikes. Chum will use these areas for foraging in the spring. This time of year, right now, we're seeing thousands of these weekly. And of course, Chinook. Now we caught Chinook at most of these sites outside the dike, almost all of them in low numbers. And it's exciting. We just got the first results back from the genetic sampling. So these are where the juveniles that we caught in the Lower Fraser came from. And you can see that spans the entire Fraser River from, this Prince George is up by the Nechako, so well north of there, right over to the headwaters in the Rocky Mountain Trench at Goat River, and down as close to home as the Harrison and the Chilliwack. So it really drives home that these habitats in the Lower Fraser, are crucial for this species. Across the entire watershed. We got a lot of other fish as well, as many other indigenous species rely on tributaries and sloughs for a part of their life history. All of these species would live as adults in the main rivers, but use tributaries and sloughs to spawn and rear in. In some cases, even sturgeon could be using these size sloughs. Certainly they historically did the larger ones. And the other benefit from sort of opening up access and through is for water quality, and particularly if flows are reintroduced, the residents of the streams that never actually go into the main river will also benefit from this. And this includes species at risk, and such as sailor sucker, brassy minnow. So lots of benefits to be had. Sort of divide these sites into two main areas, sort of the estuary sites, which are extremely tidal, upriver sloughs, which are much more controlled by freshet in terms of their hydrology. And then kind of in the middle, we have McLennan Creek and Hadsick, which really have characteristics of both. This is Tilbury Slough, our furthest west site, so very low in the estuary. And so the red line is the dike, and you can see that it crosses in two locations, and everything in between those in Tilbury Slough is cut off. So the top left picture is sort of outside the dike at low tide. This we caught Chinook repeatedly in these habitats. Top right that's top left. Top right side is inside the dike with very poor water quality, no tidal influence, and a very different species composition. We're outside the dike, we got chum, Chinook, even starry flounder, which are interesting for those of us that work mostly upriver to see. Inside the dike, it was primarily invasive species, which this is, expected. This was shown by Dave Scott a number of years ago in his master's thesis to be the case behind dikes, and including some of the same sites what we're working in. This is Addington Point, which is a very interesting site, because it was diked for about 100 years. And then in 2004, those were breached in 3 places. So it's kind of an interesting little look at what happens when tides are reintroduced. Now, the fish, these are in July. And so what we do is the graphs on the right are from a dissolved oxygen water. So it's measuring dissolved oxygen and temperature every hour for 2 days while we were working down there in the middle of July. So the top one, these yellow and red lines are thresholds. So anything and oxygen below yellow is going to be stressful. Anything below red is a killing zone for fish. So you can see at high tides, conditions are beautiful. Dissolved oxygen of 8 milligrams per liter, water temperatures, in around 17. And indeed, we catch coho and chinook, even in the summer on those high tides. But when the tide goes out, the temperature goes up to, approaching 25 degrees Celsius, and oxygen drops to below, to a level that will kill these fish. So they're riding in and out using these things. That's important because the other thing that we don't find, or something we don't find in these sloughs, are high numbers of invasive species in where the tides happen. They don't like the change in water levels, they don't like the change in oxygen, and they don't like sudden changes in temperature, where the salmon are just staying in the cold water. It certainly makes me wonder about the marsh next door across the Pitt River, which is much larger, and what the potential is there for dike breaches or removal. The upriver sloughs quite different. So as I said earlier, they're controlled by freshet, high waters through May and June, rather than a tidal hydrology. And the issues here are different. This is H. Scalachan Slough at Nikoman Island. And so this is the Fraser in the foreground. And historically, this would have taken water into Nikoman Slough, which is back there against the mountains. The dike, you can now see sort of center right crossing, cuts this off completely. If we were to reopen flow into that, there's a number of things to consider. First, the seasonality. How much of the year would it be connected at the upstream end? This is true of most of the sloughs in the upriver area. And when it was connected, when it was connected historically, it may have been dry at the upper end at low water, but during freshet, a huge flush of current would go through here, clean off the gravel, and sort of maintain the channel. So when you're talking about reintroducing flow, to consider the seasonality, the sediment. If we reintroduce enough water to improve water quality, which doesn't take that much, are we also going to be reintroducing too much sediment? There's also issues with undersized culverts downstream identified. So lots of things to think about in these, but lots of benefits to be had. Lots of potential. This is Upper Hope Slough, also cut off by a dike. This is on Chiam Reserve. Again, the dike's in red. The dark blue is the upper part of Hope Slough. I'm going to show you next a temperature log for a year from this area. So this part of Hope Slough, since it doesn't have any fresh water flow into it, very poor water quality, no salmon in it for many years since it was cut off. Prior to being cut off, it was a tremendous salmon producer and spawning grounds. We were told that there were springs in there. By Ernie Victor, and I think I've been told by Chiam elders. As we put in some temperature logs to try and find them and see how strong they were. And it was impressive. So you can see the temperature never got over 17 Celsius all summer long. That period in June when we were all sweltering in 42 degrees, that water was less than 15 Celsius in there. As the river comes up, the Fraser is driving more groundwater into these upper sloughs. So they will serve as cold water refuges during these hot part of the years. Again, an important potential that you might not think about. I've only been able to really just skim the surface. We have multiple visits in 23 sites. If you want to explore it more, all of our report cards for each sampling visit at each site, looking at sort of indicators, discussion, what species we caught, what we think the data means or implies, are on report cards that you can peruse. There's these fish sampling report cards that are fish and water quality for every site visit. and also rolled up into habitat report cards where we look at sort of in more depth at water quality and sort of a bigger picture habitat view of these things. And with that, I'd to finish off by thanking my own staff, Watershed Watch, Dave Scott at Raincoast, who helped us out quite a bit in sampling the estuary sites, teaching us a few tricks, and our First Nations partners at Chiam, Lakamo, Katesy, Stalo Guardians, Coquitlam, Kwantlen, Seabird Island, Matsui, and Skowits. We certainly look forward to continuing this work. Thank you. Thanks so much, Mike.
Yeah, and I would echo all of those thanks as well on behalf of Resilient Waters. I have to quickly shoot it over to Shawn Chartrand. This might be a bit abrupt, but he has to sign off in 5 minutes. So he's going to run us through some of the work he's been doing in terms of modeling at Addington Point Marsh with a student there, Edward Anderson. So Shawn, the floor is yours. You should have ability to share your screen. There we go.
Okay, great. Yeah, can you hear me now? Yeah, excellent. It's my pleasure to be here today, give you a very quick overview of some work that's being done by Edward Anderson. Edward is a student in the Masters of Ecological Restoration program, run jointly by SFU and BCIT. My name is Shawn Chartrand. I'm a faculty member in the School of Environmental Science. I, along with Craig Orr, am working with Edward to basically try to understand how Addington Point Marsh may respond under the future cases of rising sea levels. And at this point, we're using a numerical model to evaluate that question. And we have two different scenarios that we have successfully evaluated with the numerical model. And I'll very briefly show you the outcome of those modeling simulations at this point in time. Edward's going to be graduating this summer from the program, so we hope to keep this work going over the next couple of years and possibly expand it. So the modeling tool that we're using is a model called Marsh Morpho 2D. It's been in development over about the last decade by Giulio Mariotti. Giulio is a faculty member at Louisiana State University. He's trained as an engineer and an ecological engineer. He initially built the model as a 1D model, and the results from that were so encouraging that he then spent some time with colleagues developing a two-dimensional form of that. The images that I'm showing you here on the screen are some example applications of Marsh Morpho 2D. Giulio has done a tremendous amount of work with this model. Early on, he used it in a validation sense to try to understand if the model could, reproduce realistic scenarios of marshes that occur on the eastern coast of the United States. Basically, the way those validation runs occur is he starts with a domain that looks like this, which is essentially open water. Sea level comes in from the right here. It carries sediment, and over time, under the action of the daily tidal cycle and the sediment that is carried in with those tidal cycles, tidal marshes develop. This model is quite sophisticated compared to a lot of models because it handles two-dimensional tidal dynamics. It also can account for wave dynamics and the impacts of wind on coastal environments. It conserves the mass of sediment that comes in and out with the tidal cycle. It handles edge erosion, pond dynamics, and it can also simulate marsh migration in the upland sense in response to rising sea levels. So these two examples here would be a case for a fairly muted tidal cycle. This would be a reasonable natural analog, and this would be for a larger tidal range on the order of 3 meters, and this would be a natural analog. The model is quite exciting. We've used it in a couple cases in the Lower Mainland as part of the MER program, and Addington Point is probably the first chance that we've had to use it in a spatial sense that's more consistent with how the model was envisioned for application, meaning the size of Addington Point Marsh lends itself to the model use. So here are some quick results. At this point, we've run two scenarios through the model. A simulation takes about 12 hours to run for 100 years, a double that for 200 years. We have runs out to 500 years. Right here, we're looking at runs for over a 100-year time frame, or I'm sorry, 80-year time frame. This would be in the existing condition of the marsh today, developed using a variety of LiDAR data sources. All we did was imposed a rising sea level on this. In this case, we imposed a 1 meter sea level rise by the year 2100. And within that, we had a constant or a fixed sediment concentration of 20 grams per cubic centimeter of water. This is what the marsh looks like again at present. This is what the marsh evolution may be at year 2055. And this is what the marsh evolution looks like at year 2100 under this rising sea level scenario. 20 grams per cubic meter, is a best estimate of what might be an average daily input of sediment to marshes along the Lower Fraser. But I must stress that there's a lot of uncertainty there, and we hope to be addressing that in the future with getting out in the field, installing instrumentation, and trying to learn about sediment loads in marshes along the Lower Fraser. Now, this would be a case where there's an offsetting potential component that could interface with the project. And so we take the existing marsh surface and instead we construct some starter channels in this lower southeast corner of the marsh. And we also include some additional breaches in the dikes themselves. And so this would be what the marsh looks like at year 2055 as simulated. And this is what the marsh may be at year 2100. The colors, I didn't mention, are just elevations. The darker colors are higher elevations. The lighter colors are lower elevations. So for both cases, you can see that in general, the spatial arrangement of tidal channels is quite similar. There's not a lot of differences between those two, but we're still early on in our work, and Edward will be working over the next month to better characterize and contrast the outcomes for these simulations, and then hopefully set the stage for using the model as a decision tool within the restoration framework and ideas that are being kicked around at Addington Point. I'll leave that at that. Thank you for your time.
Yeah, thanks, Shawn. And you're running off to a defense of some kind.
I am.
Is that right? Okay.
Yeah, have a great meeting. Thanks.
Thanks for joining.
You're welcome.
Yeah, as I put in the chat, feel free to throw any questions or feedback or anything like that into the chat box. At this point, I'm going to hand it over to Zach Sherker from the UBC Pacific Salmon Lab, who's going to share a little bit about the work that's been happening at Colony Farm on the Coquitlam River with a unique floodgate over there.
Awesome. Thanks so much, Dan. Thanks so much, everybody, for having me. This is such an important meeting and very interesting on my end to see all the other work going on. Can you see everything okay?
Yeah, if you hit that slideshow button right now, we're seeing, there we go, perfect.
Okay, perfect. Okay, yeah, so this is a effectiveness monitoring program looking at juvenile salmon movement through a self-regulated floodgate compared to like a basically crappy old floodgate, which would be representative of some of the structures in the Lower Fraser. And we're using pit technology to basically track fish movement through these structures and compare at different tidal cycles. And so just a quick background, basically, yeah, this is a pit tagging environmental monitoring study looking at juvenile salmon passage. We're comparing movement at one self-regulated gate, one of only two in the Lower Fraser, but likely sort of our best chance to make fish-friendly infrastructure that will actually last in the coming years. We're comparing that movement to one unremediated gate, And then we've got one decommission gate at sheep paddocks that is actually going to be chained open to just allow water and fish to move through as they likely naturally would, just through a culvert instead of a natural opening. We're focusing on juvenile coho and chinook moving into these overwintering habitats, as Dan was mentioning, very, very important habitats for their growth and survival on their way out to the estuary. And then we're actually going to be experimentally examining the automated floodgate to see how we can best program it to match fish movement compared to the tidal cycle in different water levels. Just the objectives are to assess the fish passage and compare them using pit tags. It's a before-after control impact study where we'll actually be able to, working with KWL, who actually built the structure, to actually alter the function to basically maximize its benefit after the hard work of installing and paying for it is all done. Experimentally, altering the gate, and then compare passage between different species and size of juvenile salmon. But we've got lots of technology in the water to look at water levels upstream and downstream, oxygen, dissolved oxygen levels, as well as temperature, and actually angle meters to see when the floodgates are opening under different tidal conditions. And so we'll be able to document passage during the spring out migration, as well as the migration in for overwintering in the fall, compare growth rates through recaptures in the upstream habitat, monitor the water quality, and compare them between those, and actually survey native and non-native fish populations, which is sort of building off of Mike Pearson's work as well as Dave Scott's. And just a quick overview of the methods. So these are two of our sites, the self-regulated gate and the crappy old floodgate. And what we plan to do is basically put pairs of pit antennas on the upstream and downstream end so we can get directional movement. And it'll allow us to look at passage success. So how many times are these fish actually approaching the structure before they can effectively pass through, as well as efficiency. And then we will be using block nets to basically seed these downstream forebays with tagged juvenile salmon, both wild and hatchery. Leave the block nets up for 24 to 48 hours to give the fish a chance to acclimate and potentially move upstream through the structure. And we'll be taking a page out of Mike Pearson and Dave Scott's book, using minnow traps and pulsating to capture wild fish to compare to the hatchery movements. And the seeding will occur 1 to 2 times a week throughout the overwintering migration. And then those pit tags will allow us to see survival as well as out-migration success in the spring. So this is just sort of what the full setup would look like, with a block net on the downstream end, pitching off fish, allowing them to get acclimated to the forebay, as well as you can see our pair of pit antennas on the downstream end of the self-regulated gate. Just a quick overview of where we are. We're in Colony Farms on Coquitlam land. And our sites are relatively close to each other, which is nice. So here's the self-regulated gate. Just across the way, we've got the top-mounted gate. And then just up a ways, we've got sheep paddocks, which is an outflow of Mundy Creek, which has been basically restored in other ways. But one of the main ways is a side-mounted floodgate's been put in that we're actually going to be able to chain open. We'll be using pit technology. So pit tags are basically small glass tubes about the size of a Tic Tac, and you implant them in the abdominal cavity of the juvenile salmon. And the metal coil that you see there, it actually lays dormant. The tag lays dormant, so it can survive for years and years and years, because it doesn't have an attached battery, but it's externally charged by pit arrays or magnetic arrays. And when it goes through these antennas, it basically picks up an electron, which charges through the coil, sends out a radio signal with a specific fish ID, and we can see exactly what fish was released. And we've got all sorts of information that we'll be gathering. So the size of the fish, the species, condition, things like that, where it was released. And so when we set out to do this project, we had a pretty good idea of what we were doing. We originally designed these rectangular antennas, which are quite commonly used. But unfortunately, even though we had, a long installation period, a long time building these things, they didn't work successfully because the wire was so close to metal interference in the floodgate walls. So we worked with InStream Consulting as well as Art Bass from the Pacific Salmon Ecology and Conservation Lab to basically develop these these sort of infinity loops, as we've called them, which is a brand new pit antenna design. And instead of having the wires all directly basically on contact with the frame, it brings the wires away from the potential metal interference on the walls, and it results in these sort of multiple coil antenna designs, which are actually really, really effective at blocking out noise. And that's sort of the full size. They're quite large antennas, so the floodgates can range from about 12 feet across and 6 feet tall. So no small feat to fill that entire thing with magnetic charge. And so once we had our final design, we basically went into mass production. Kind of had a sketchy overload moment, brought them out to the field. We had to actually work with the tides, so we were installing mostly in the middle of the night, which is has its own safety protocols that go along with it, and really thankful to have everybody out that could come and help. The installations went actually really smoothly. Right after we installed, we had the atmospheric river, which is pretty much the ultimate test for these antennas, and they withheld, which was great. We actually have designed a new antenna design for another site, the sheep paddock site, which is a 4-leaf clover. We're kind of just getting crazy with it now, but they're really, really powerful antennas, and they've got an amazing detection efficiency and ability to reduce noise. And we're currently working with InStream as well as Bailey Environmental and other members of the lab to basically put together a methods paper so other people can use these antenna designs to investigate things like floodgates, culverts, other things that might have metal interference, but are really important to see fish passage through. And so once we finally had everything set up, we went into pit tag some hatchery coho, released them in our experimental design, and within 20 minutes, we had our first upstream movement. Detections at all 4 antennas. It took about 1.5 minutes for the fish to get through. So very promising that the system will work. It's up and running. And now we've just got to figure out a battery situation. But this is still, we've come a long way in the little bit of time that we've been working on this. And in the meantime, we also wanted to continue some of Mike Pearson's work, which is looking at basically sampling and comparing fish populations upstream of each of these 3 floodgate sites. And what we've seen is a lot of really interesting fish species. So we've not only got coho, but Chinook that are coming in from other parts of the Fraser. There's no native Chinook in Coquitlam River. So really cool to see that other fish populations are using these important habitats and coming in. We've also got really large cutthroat trout, sculpins, 3-spine sticklebacks, red-side shiners, lots of species that we really do like to see. And just a quick overview of what we've seen between the sites. So at the self-regulated gate, we do have quite a few native species. We also have some invasives, such as the dojo loach, the pumpkin seed, and some bullfrog tadpoles. As you can see at the sheep paddock site, which is open all the time or much more frequently than the self-regulated gate, we do see a stronger native fish population, it supports Dave Scott's findings. We do also see some invasives, but they can't seem to get a stronghold just when the native species are actually up and running in these areas. And then just to put that all into perspective, upstream of the gravity drain or the crappy old floodgate, we see not a lot of fish species, and what few fish species we do see are often invasives. And this will be really interesting to pair with our angle reader data to see how often the floodgates are moving and actually looking at the dissolved oxygen and temperature upstream to try to see what's actually driving this mixture of likely passage as well as habitat quality upstream. And yeah, this has been an amazing, team that we've got. We've basically got a superstar team that Dan Straker really helped put together. But we're working directly with Coquitlam First Nation, Resilient Waters, Watershed Watch, DFO, us at UBC, Pearson Ecological, KWL, who actually knows a lot about they built the self-regulated gate, and they're going to help us actually alter its movements to try to sort of improve fish passage. And then we've had a lot of volunteer opportunities from both InStream and Bailey Environmental, who have donated hours and hours and hours of work to this project. And it really it never would have been possible without all of these sort of minds melding together. So thanks, Dan, for the stage, and I really appreciate any feedback.
Yeah, thanks so much, Zach. And Zach has accomplished nothing short of miraculous on this project, being thrown many challenges and kind of rising to the task to not only kind of achieve what we hoped, but also like to make some new partnerships like InStream and bringing along his former co-workers at Bailey to like really make this thing a special project. So excited to see what the next couple of years look like as well. So thanks so much, Zach, for all your work on that. Because we've got a lot to get through, I'm seeing a few questions pop up in the chat. Zach, if you don't mind getting on those, there's one from Betty and then one from Rob. But because we've got a lot to get through, I'm going to hand it over to Patrick to talk a bit about the restoration side of things and our prioritization or opportunity identification process. And then we'll have a break right after that. So Patrick, over to you.
Great. See if I can get these slides working properly. Can everybody see that all right? Oh, except I'm on the wrong slide. Slip back to the beginning of the presentation. So thanks, Dan, and yeah, really interesting presentations thus far. Happy Earth Day, everyone, as well. If you feels like it is fitting to be discussing these issues on Earth Day. So Mike had a lot of cool photos of fish, and I'm going to talk a little bit more about sort of the less flashy part of this this work, which is the prioritization study that KWL has been leading. And really, this is you know, the planning and evaluation process that we've been supporting to help select and prioritize projects to move forward with. To really address some of these issues that we're seeing in the field with regards to you know, impairments and impediments to fish passage and degradation of fish habitat. I just want to highlight that while KWL led this study, it has been very much a collaborative process. This has been a great project to work on because of the collaborative nature of the work, and all of the parties whose logos are shown are have been involved to some degree. And also, just speaking of logos, I just want to give a shout out to Carrie Lynn Victor for the Resilient Waters logo design too. It's a very cool logo to represent this project. So just in terms of the project identification prioritization process, Dan alluded to this, but we've been at work with it since late 2020 and are just sort of wrapping up this phase of the work right now. It has been a 4-step process, which was in some ways delayed because of the field work and COVID. The field data that Mike has been collecting has been an important part of the latter phases of the prioritization process. And so, you know, we've sort of held off wanting to incorporate that field work, which was delayed. So the steps were, the initial step was an inventory and mapping phase, which really focused on collecting spatial data and mapping that data out. And you've seen some of the, if you've been on the Resilient Waters website, you'll have seen some of the results of that first step, which is an interactive online map, which shows the flood infrastructure and some of the areas that we've identified for improvements within the Lower Fraser. We then took that sort of broad mapping of infrastructure and went through sort of a screening process, first through a desktop review to develop an initial site list for investigation. That we called our long list of sites. And then a more detailed screening process where we conducted based on preliminary site visits, where we looked at those sites in more detail in the field and began to determine what ones might be the best suited for some of the field investigations that Mike and others have been leading. Through that detailed screening process, we also began to develop a series of project fact sheets to highlight those projects in more detail and discuss some of the issues at each of the sites. And really what we're in now is step 4. So that's taking the field data, which Mike has been collecting, some of the engineering information that we've also been collecting from owners and managers of some of the infrastructure to develop a final list of prioritized sites and evaluations that go along with those sites. And so we'll be incorporating all of this information into a final recommendations report, which will be finished up very, very soon. So again, through the initial inventory and mapping phase, we identified, almost 1,500 kilometers of sloughs and waterways that are behind about 250 kilometers of dikes. There are at least 156 water control structures within the Lower Fraser. And through those two screening processes that I just mentioned, we narrowed this down to about a list of 26 high priority sites, which have been the focus of the fieldwork. And these represent sites that are geographically diverse. They're broadly representative of the types of projects that are really needed to improve flood infrastructure for salmon. So things like pumps and impacts of pumps and pump stations and flood boxes that don't open as regularly as and provide very good fish passage. And also projects that look at the potential of reconnecting important floodplain habitats that have been cut off from the river by dikes. So the Addington Point and Pitt Addington sites that Mike highlighted are examples of those. And we think these projects could make a real difference in terms of salmon habitat accessibility and connectivity in the Fraser River floodplain. So just an example of one of the fact sheets we've been working on producing. This is one for Backwash Slough, which is actually the upper end of Hope Slough, which was a site that Mike talked about. And this would really be a project that would be the first step in actually providing fish access and water flows into the top end of Hope Slough, and one of the priority projects that we've identified. So to evaluate the individual projects, we're now in the process of using the field data that was collected and some of the other data that we've collected on the structures themselves, and running our sites and projects through an evaluation process to inform our final prioritization of projects. We're using a set of evaluation criteria for this process, and there's really sort of three major categories that we're looking at. So the ecological side, obviously, our goal is to improve fish habitat. And so, we're using the data that Mike has collected to assess the amount of types of habitat that might be reconnected or restored, the particular species and populations that are likely to benefit, and what is the existing habitat condition and the recovery potential of that habitat. As well, on the engineering side, we need to understand sort of how viable or feasible are particular solutions. Is there any complementarity with planned upgrades? So, a lot of this infrastructure is critical for flood protection. It's at various stages of the life cycle. And so there might be opportunities to, improve flood protection through replacement of infrastructure, but also address some of these fish-related issues as well. We also need to ensure that we're managing flood risk by, choosing solutions which don't reduce the level of flood protection at some of these sites. We're also concerned about things like climate change resilience and costs as well. And then as we've gotten into this project, we also have recognized that, there's a whole range of sociocultural criteria that these also influence the ability to move these projects forward. So things like whether there's local First Nation support or political support. In many cases, the local governments are the owners of this infrastructure. Are there challenges or benefit or synergies with adjacent land use? And are there social and economic co-benefits that could be realized from the projects as well? So to introduce you to a few of the high priority projects and to show you how we've been evaluating projects, I wanted to walk through a couple of our highest priority sites. So the first is Tilbury Slough. This was one that Mike mentioned as well. It's located on the south arm of the Fraser River in Delta. So it's our westernmost site within the study. And Tilbury Island was once a separate island in the Fraser, but the island was connected to the mainland as part of industrial development. So the Delta's perimeter dike actually extends from the main part of Delta across the ends of the slough and around the island. So you can see this is at the existing McDonald pump station, which is at the south end of the slough. The reach of the slough outside of the perimeter dike, which is sometimes known as Gravesend Reach, you can be seen in the background, and then in the foreground is Tilbury Slough, the existing pump station, the existing flood box. And this is really the problem at Tilbury Slough. So the flood box is an older flood box with a top-mounted flap gate. The pump station itself has a non-fish friendly submersible pump, an impeller pump, and that pump actually runs intermittently throughout the year, even in, in all tidal conditions, even at lower tidal levels. And you can see the result of sort of this slough being cut off by the dike and this infrastructure. We have really poor upstream water quality, especially in the summer. So you can see how bad it actually gets in the summer. And some of Mike's field work has documented those conditions. And so what are we looking at a proposed solution? Well, two things really: to retrofit the existing flood box with a self-regulating tide gate, or sometimes known as an SRT. This would be a tide actuated control gate. So the idea is that water levels outside of the slough would control the opening and closing of the gate. This is actually the gate that's shown in the picture is actually a similar one to the gate that's installed at Wilson Farm that Max just talked about Zach talked about in his work. And then also looking at the pump station itself, looking at whether the pump could be operated to reduce the amount the pump is running, to reduce potential mortality to fish, and also to potentially install a new axial flow pump, so a more fish-friendly pump style as the lead pump in one of the existing pump bays. So I won't go into a lot of detail on this, but this is the way that we're evaluating the projects. So this again shows the different evaluation criteria we're using. We're giving them sort of simple ranks based on sort of the information that we have under each criteria. So again, the ecological is largely sourced from the work that Mike and his team have been doing, engineering from our conversations and documents that we've received from engineer owners, and also the sociocultural criteria based on the conversations that we've been having with the owners, with First Nations and other stakeholders in and around these projects. So you can see sort of how these projects are being evaluated. Just to highlight another project that is in our high priority project list. So this is Taylor Road Slough. This is a smaller slough that's a tributary of Nikoman Slough, which runs around Nikoman Island, kind of more of an upriver site. It's adjacent to one of the reserves that is a reserve of the Kamal First Nation. And so we've been discussing this project closely with the nation. You can see that the slough is currently separated from Nikoman Slough by a dike, and there's an existing flood box through the dike, approximately at the locations shown. And just to give you an example or a description of the problem at this site, so we have the flood box culvert that actually runs through the dike is collapsing and is partially blocked and really not very functional. And you can see that there's also a top-mounted flap gate. This of all the infrastructure we've looked at in the Lower Fraser, this one is probably the one that's in the worst condition and really needs attention, both from a flood protection perspective, but also obviously from a fish perspective. And this culvert or flood box actually runs through an existing dike that is also in very poor condition, probably one of the dikes that is again in one of the most poor conditions in all of the Lower Fraser. This dike was actually built in a very big hurry in advance of the 1948 floods, and so it hasn't really been upgraded since. So you can see even after the recent November atmospheric river events, this is some of the damage that event caused, and that's actually there's some repair work that's probably starting on Monday to address some of this sloughing on the face of the dike. And again, so just what's the solution at this site? So this is the solution we're looking at here is to install a much larger flood box and install a manual slide gate. So again, those top-mounted flap gates, really the flood risk here is with freshet, which is very seasonal. And so a gate that could be left open during most of the year and only closed during the critical flood periods is the solution that we're looking at. And shown on the right here is an example of the new gate that was just installed at Azeez Slough, which is also one of our higher priority projects and actually the first to have the work completed. This was a project led by the district of, recently completed by the District of Kent. And again, just the sort of evaluation, an example of the project evaluation matrix that we're using, and we're doing this for all 26 sites. So again, both ecological engineering and sociocultural criteria. I just wanted to finish off by highlighting some of the issues and challenges that have come up commonly in our conversations with owners of infrastructure and some of the communities that we've been discussing moving these projects ahead with. A few of the ones I wanted to highlight were just that the lack of documentation of existing conditions at a lot of these sites. So again, a lot of our flood infrastructure in the Lower Fraser was built in the 40s and 50s. Some of it has been upgraded since, some not. And so for a lot of those earlier constructed structures, there's just not a lot of documentation of what those structures are, what they were designed to do. And so we're really having to do a significant amount of investigation to figure out what's going on at some of these sites with respect to infrastructure. And I think that's a common issue across a number of these sites. Mike and to some degree Shawn have already highlighted this issue, but the importance of fine sediment issues. So as we know, when the Fraser River runs high during freshet, it carries a lot of fine sediment with it. That can be both a good thing from an ecological perspective in terms of accreting and creating new marsh and marsh habitat, but it also provides some challenges. When we introduce water and fish into some of these areas, we're also introducing fine sediment, and that comes with its own challenges to manage. We've also talked about who will manage and maintain this infrastructure. We have, some of the folks that we're talking to are very interested to be involved in moving these projects ahead, but ultimately someone has to take responsibility for new gates or structures once they're managed. And so who will manage and maintain them in the long term is something that we've had a lot of conversations about, and something we're, that's unique to each individual project, just because there's different challenges with each site, different ownership and management regimes. And so, but this is something that has come up commonly as well. And then I think Mike also highlighted this, but there's just a need to combine other restoration projects to maximize the benefits of these projects. So improving the habitat upstream of some of these structures that we would open up for fish passage will really help to maximize the value of these projects. So where are we headed from here? So really what we're doing is wrapping up the prioritization phase, and we're moving into implementation. So by the end of April, which is coming up very quickly, we're going to finalize all of the project opportunity fact sheets and complete our final recommendations report. And that will be available to anyone who wants to take a look on the Resilient Waters website. And we're entering phase 2 of the work, which is really to, with Resilient Waters, lead implementation of 3 to 4 high priority projects. So going through the sort of feasibility, design, and construction stages of implementing those projects. And then also continuing to inform and support project implementation by others. So, the project like at Azeez Slough, where District of Kent was already undertaking a replacement of the infrastructure, and Resilient Waters really worked to ensure that that project was done in a way that was going to make the best possible improvement for fish and fish passage. So that's where we're at. Excited to head into the implementation phase. There's my contact information if you have any questions or want to discuss. And again, a big thanks to the KWL staff that have been involved in the work thus far, all of the First Nations staff and community members and municipal and Addington district staff that we've discussed these projects with, as well as some of the more core Resilient Waters team who have been involved in specifically in the prioritization work. Thanks very much.
Yeah, thanks so much, Patrick. That's great. Great stuff. Yeah, a lot to dig into there, and there's a few questions lingering in the chat. I'd just like to, I think it's probably a good time for us to take a quick break. I'm gonna say, let's come back at 10:55, if everybody's cool with that. And then Lina Azeez from Watershed Watch Salmon Society will give a presentation on some of the systems change aspects, building back better together in flood recovery, stuff that was alluded to earlier, and plus some other cool things to show off. So let's take a break till 10:55 and we'll see you then. I can give you a better introduction than that. Lina Azeez of Watershed Watch Salmon Society, Connected Waters Campaign, works closely with Resilient Waters. Thanks, Lina. Go for it.
Thank you. Sorry about that. Just getting back off the break. Mine's all over the place. Hi, everyone. Really nice to be here and really nice to see all the wonderful work just kind of come together in one place today. So I'll just talk briefly to how we are working together around the systems change portion of our work on floodplain management and fish-friendly flood protection, and some of the best practice type actions we've been taking to perhaps support this work better for engineers, technicians, planners, and people who are doing this work. So I'm sure everyone here is already aware, but just very, very quickly, our campaign called Connected Waters launched in 2016 with this map where we identified the issue that's been discussed quite at length today. I just actually want to take this opportunity to say it's been really wonderful to see how far we've come with Connected Waters and with Resilient Waters and the collaboration that's happened across the region to look at the impacts of our flood control structures on fish and fish habitat, and just the multiple opportunities and multiple benefits that we have before us to do better. And it's actually been a little overwhelming to see the studies and the research and the results coming out of this. And I'm really looking forward to the next phase of Resilient Waters where implementation starts to happen. So as part of some of this work, Dan and I and some volunteers have been wanting to put together some case studies to support decision-making at the local, regional, federal, First Nation government level when it comes to what it means to improve passage for fish in a way that also continues to protect our communities. So to that end, we have got two of a trifecta of reports that will be released over the course of the next few months. One is a case study on pump stations and fish passage in the Lower Fraser, and the other is looking at tide gates. And a third one, we're working with a UBC student over the summer to look at floodplain management in different jurisdictions near and far. So keep an eye out for these as they'll be coming out in the next few months. A second series of work that we've been working on has been the creation of a few animations. And I'll share the link to the animations so you can take a look at them more fully. But basically, the aim of this was to help people understand what poor flood control looks like when it comes to fish and fish movement and fish death, because that's a huge issue, and how we could better improve it by using technologies that already exist. And we're looking here at mostly gray technologies, but we did explore some green-gray options as well. And it's a very complicated issue when we start to talk about water and fish and movement. And so we wanted to simplify that. So we created animations to help do that. It was an iterative process. We went through 3 different sets of animations to try to find the perfect, to try to portray this issue in the most perfectly imperfect way possible. And over the course of a couple of years, we were able to do that. And these animations have been supported and advised by biologists and engineers in order to ensure that they were as accurate as possible, considering they are still animations and kind of cute and cartoony. So I'll show you a couple of them. So this is an example of an impeller pump station, which is often fish unfriendly. So as you can see, it's a propeller style. If water is getting pulled, fish are also getting pulled and often getting killed in the mechanisms or maimed in some way. And so it's not a very good system. show you one that's fish friendly. So then we explored what a fish friendly axial pump might look like. We also have an Archimedes on the website if you're interested in seeing what that looks like as well. And in this case, you've got water coming through, and because of the design of the propellers, the fish are able to move through in a more fish-friendly way. We're not saying any of these are 100%, but the mortality rates are expected to reduce with fish-friendlier pumps. We also looked at some gate options, and so this is your typical fish-unfriendly top-mounted gate. Many of these are installed in and around the Lower Fraser. And with these systems, the gates are barely open and not many fish can move through. You have also less flow of water unless there's a huge pressure from behind. And then a fish-friendly version of this would be something like the sluice gate, which is open almost all year, except for when the water is high enough to trigger the gate to close. As you can see, it moves water and fish through the system quite well and can provide access for fish to good habitat. So so I will share the link so you can see all of the animations that we have created there on the Watershed Watch website with descriptions for each of them. And if anyone has any more that you'd like to see us kind of explore, please do share them with Dan or myself, and I'm sure we can work something out. Finally, I just wanted to touch base to update some of you on our floodplain advisory called Reimagining Floodplains. So we're an emerging group of BC-based organizations and experts, but we are also advised by our colleagues down in Washington State from Floodplains by Design. So that's the Nature Conservancy who started Floodplains by Design in Washington State. And we've come together because we were really concerned about the state of managing our floodplains in the region. And we came together almost at the same time as the atmospheric river. So our first meeting was right after. And of course, all of our attention has become focused on what can flood recovery look like and what does it truly mean to build back better? And what are some of the management and governance conversations that need to be had in order to ensure that as local governments and First Nations and the province are looking to build what was destroyed, we don't do so in a way that continues to harm fish and habitat. Instead, we're able to look at the multi-beneficial opportunities that do exist if we're to work in a more collaborative, more regional approach. So our goal here is, again, like looking at the flood recovery opportunity, because this is an opportunity, as Jillian mentioned at the top of this meeting. And our focus here is not just to build back better through Sendai, but with a more regional approach, to build back better together, local governments and First Nations working together to decide on what those build back better together principles would look like and what approach should be taken. And also in the short term to figure out or support proactive, progressive criteria for all of that funding that's been slated for recovery and resiliency and restoration work. So just as an example of some work we've done on this, more recently with the leadership of Tyrone McNeil from the EPS, we had an audience with Minister Bill Blair and his staff, as well as Minister Farnworth and his staff, and a number of First Nation leaders up and down the region who were affected by the floods, where we could present to them this concept of building back better together, the need to discuss principles as a region, and put forward the need for a more comprehensive meeting between local governments and First Nations and necessary interested NGOs to participate. And that's something perhaps you'll hear more about as we organize and put together for hopefully June. So that's, so very briefly, that's some of the work that we've been doing. And I'll turn it back to Dan.
Awesome, thanks, Lina. And thanks everyone who's been involved in those animations. Case Lackman, I think, was here earlier, maybe not anymore. And then an animator, Carol Alas. And then thanks to Deb Carlson and Tamsin Lyle and Dave Zinder, Jillian and Tyrone and Patrick for their involvement in this, this most recent effort on the Build Back Better Together. Okay, with that, we've reached the point that you're all waiting for, which is the breakout groups. So I'm about to send everybody into, or not send you there, you're actually going to get to test out a new feature that I haven't really used before, but we are going to have a breakout group on research where Mike and maybe Zach, if he's still hanging out here, will be going. And then there'll be a room for restoration and the kind of prioritization process that Patrick will be leading. And then a systems change group that's like best practices and the Build Back Better Together kind of response that Lina was discussing there. So those are our 3 breakout groups. I'm going to open up all the rooms. We're going to basically go 25 minutes for the first round. We'll come back out, do a quick swap so that you get to go to one more breakout room for 20 minutes. And then we'll save some time for a little report out at the end. And we will then wrap up. So I'm opening up all the rooms. Well, thanks for sticking with us through to the end here. We're going to have a little report out from each group. I wonder who's feeling brave enough to start us off. Lina and Jillian, are you guys feeling brave?
Sure. Jillian, did you want to start?
Sure. Thanks. Yeah, we had a good conversation in the systems change group. We had 2 very different conversations, which was by design. So the first was talking about reflections on what had been presented so far and reflections on, I guess, how do we affect systems change or what would we like to see? And so there was some good conversation on looking at pathways of change. So managed retreat as an end pathway, sort of initial flood management or recovery as sort of the first step in that pathway, and then ending up in something more resilient. And so how do we put that into practice in this area? And I think, at least for me, the culmination of that conversation was that each of the participants in our group was interested in seeing change. It was just there were so many barriers to how to get it done, or even when we have an idea of what we'd like to see, it's still difficult to get it funded. So we have grand ideas, we have lots of planning, we have lots of systems. There are, for example, integrated floodplain plans that we are already using, but it's there is that bit of a barrier between what we like to do and what we can do that we still have to work on. And the second session, we had everyone sort of talk about the amazing and inspiring things that they're doing to inspire systems change. And we had, it was quite DFO heavy, which was interesting, but everyone from DFO had a slightly different perspective and a slightly different answer in terms of how they impacted systems change. So that was pretty awesome. I think the very similar barriers though to moving systems change forward in terms of funding is a concern, getting everyone together. There are so many decision makers, and I think Murray Manson said it the best, where when you're looking at the floodplain, or sorry, that might have been Spencer, when you're looking at the Lower Mainland, there's just so many different people, projects and things like that that are happening, and so many different things that we need to use our floodplain for, and getting everyone to work together in concert and have sort of a unified vision can be challenging. But one of the good things that came out of that conversation was City of Burnaby is really looking to do some fish-friendly flood upgrades. So yeah, I'm going to self-nominate David Lee. He's looking for partnerships and assistance. So anyone looking to put in a fish-friendly pump station, talk to him. Okay, that's all for us.
That's great. Thanks, Lina and Jillian. Sounds like some good conversations. Patrick and Oscar, are you guys feeling ready for it?
Or I can share what our group discussed. So we kind of had an open-ended approach to the discussion. So since we talked about the prioritization in the presentations, we sort of were looking for some feedback or thoughts on what people had heard and the direction that we're moving in. We heard that people don't want to lose the fact that, by limiting ourselves to these 26 sites, that there's actually a lot of other sites that out there that that still need to be addressed and that aren't okay. And so just making sure that like the sort of broader issues are, and the broader, you know, sites that we've identified are captured in some way in this process. On the flip side of that, we also heard that, you know, is 26 sites too many? And do we need to sort of like limit ourselves to, you know, what are the really imminent projects that need to be moved ahead? So I think there's a real desire to focus, but also a real desire to make sure that we're like addressing the systemic issues related to flood infrastructure as well. We talked about, you know, the prioritization approach we took, which was more to like look at individuals projects, but there's also a desire to look at the issues as a whole and like how much, you know, these sites have, or how much flood infrastructure has affected the Lower Fraser in total. So, and how much these projects could ultimately benefit that. So, you know, we talked about needing to examine the Lower Fraser holistically, needing to look at flood infrastructure as a system as well. We talked about like whether these projects would actually have any flood protection benefits as well, like by providing more conveyance or flood storage for the Fraser during freshet, and if that, you know, could be a benefit to flood protection as well. So Steve Litke and I are going to maybe have a follow-up chat about that a little bit. Yeah, I think that's the main sort of things we talked about. Oh, at the end, we were just starting to talk about whether or not like having some sort of standard performance criteria for flood infrastructure would be helpful to move projects forward, so that, you know, it was more standardized and it was more of an expectation, and those expectations could be made clear through some sort of standard design criteria.
Great, thanks, Patrick. Yeah, that sounds like a great idea. Yeah, helping anybody with capacity is obviously going to be a big boost. So that is one area where Resilient Waters wants to try and help. So we'll keep that in our minds. Okay, the research group. I'm going to take a stab at it and then probably get a bunch of stuff wrong, and then Mike and Zach are going to help correct. So there was, so the research group, we were talking about a mix of Zach's work at the Colony Farm with the PIT, the passive integrated transponder setup, as well as Mike's site assessments of the 26 sites. So there was some conversation about like, it would be great to have some of these pit setups elsewhere, like in culverts along railways or elsewhere along the Fraser River, and that would be great. Zach mentioned that Canadian Wildlife Federation, so Betty Ribolato, who may still be here, is looking at that for all of BC, and it sounded like railways was identified as one of those fragmenting agents. Yep, and John mentioned that he was involved, John Wearing was involved in some work in the 80s on the Thompson River that was looking at this issue in particular. Then we talked about birds with James Casey, because you got to talk about birds and about the potential for like kind of co-referencing, I guess, like birds returning to habitats alongside restoration, which would be pretty cool to have at some of the marshlands, maybe particularly Addington, Point Marsh. And in the second round, there was a little bit of talk about like making sure to be documenting, or I'm not sure if it was making sure, this is maybe where I need a correction, but like it's important to monitor after you do the restoration to show the improvement of the habitat. I think that was kind of the point, and definitely that's something we want to do, but this is one of those weird ongoing, maybe systemic issues that not many people want to pay for that monitoring after restoration happens. And then there was a couple of questions about, oh yeah, there was Millie Kyer from BCIT asked, both maybe from the FWR side of things and the Ecological Restoration Program Masters, you guys are looking for projects to connect up for students in the fall. Is that right, Millie? Or is that more immediate?
Yeah, I mean, it's all the time, really. Like FWR diploma programs are good for some of that more basic stuff, the birds monitoring or post-restoration monitoring. BSc is kind of like a 2-term project, and MSc is more like a 3-term project, depending on intensity. Yeah.
So we'll be hooking up some ways to connect with Resilient Waters, but also if there's other folks out there right now that are looking for some support from students at those. Yeah, there we go. Valerie Zimmerman. Yeah, exactly. Get in touch with Millie, right? You could, yeah, that would be great. Yeah, that was essentially it. Mike or Zach, anything to add?
You nailed it, Dan.
Nice. Okay, that's basically it, everybody. I don't have too much to say. Just maybe quickly a thanks to our funders. I'll just whip this up here very quick and sloppy like. Yeah, we talked about a lot of different work today, but there's, this is like Zach's work has been joint funded by the Fish Wildlife Compensation Program and our SRIF grant. Most of our work is falling under the Salmon Restoration Innovation Fund, which I guess has officially been announced within the last 15 minutes or something. So we are allowed to talk about it now, I'm pretty sure. So all the stuff we're talking about in terms of restoration and research for the next kind of 2 years is a lot related to that Salmon Restoration Innovation Fund. That building back to get better together stuff with Real Estate Foundation has been a big support on that. Pacific Salmon Foundation has been chipping in for some equipment and the genetic analysis, that kind of stuff. And I guess finally, just a huge thanks to everybody on the team, every one of you for coming out and joining us. This is a huge project and lots of fun to be working on, doing some serious stuff, especially with our First Nations partners. Thanks so much for being a part of it. And yeah, that's it. Thanks, everybody. Feel free to linger if you like.
Thanks, Dan. Take care, everyone.
Thank you. Thank you. Bye.
Thanks, Steve. See y'all later.
Thanks. Bye.
Thanks.